Welcome to the DIY Honda Garage channel. In this presentation, we will address the diagnostic trouble code DTC P0141, which indicates a malfunction in the heater circuit of the secondary heated oxygen sensor, HO2S, specifically sensor 2, on the Honda CR-V models ranging from 2017 to 2022. This code is crucial as it relates to the vehicle's fuel management and emissions controls, which are essential for optimal engine performance and compliance with environmental standards. The secondary HO2S is responsible for monitoring the level of oxygen in the exhaust gases after they pass through the catalytic converter. This data helps the engine control module, ECM, adjust the air-fuel mixture for efficient combustion. The heater in the sensor is intended to ensure proper operation, even during cold start conditions. When issues arise with this circuit, it can lead to increased emissions, reduced fuel efficiency, and potential engine performance issues. The DTC P0141 refers to a malfunction in the heater circuit of the secondary HO2S, or sensor 2, which plays a vital role in the vehicle's emissions system. This sensor is specifically responsible for detecting the oxygen content in the exhaust gases after they have passed through the catalytic converter, positioned effectively post-catalytic converter in the exhaust system. The heater circuit within the secondary HO2S is crucial for its operation, especially during cold conditions when the sensor would not otherwise reach optimal operating temperatures quickly. When the heater malfunctions, it prevents the sensor from accurately relaying information to the engine control module, ECM, leading to potential adjustments in air-fuel mixtures that could degrade performance. Hence, it's imperative to troubleshoot this DTC to prevent further complications related to fuel economy and emissions compliance. Several possible causes can trigger DTC P0141. Firstly, a short in the IG1 ACG wire can occur, which would affect electrical supply to the secondary HO2S heater. This wire's integrity is crucial, as it connects the secondary HO2S to the powertrain control module, PCM. Secondly, the secondary HO2S itself may be defective. It could have an internal failure that prevents it from heating properly. Lastly, an open in the SO2HT wire may also lead to this DTC, indicating a break in the circuit that restricts proper current flow. Each of these causes can lead to improper functioning of the heater circuit, ultimately affecting the performance of the vehicle's emissions control system. When DTC P0141 is present, a driver may notice several symptoms directly linked to the vehicle's performance and efficiency. Decreased fuel efficiency is common, as the engine might not be burning fuel as effectively due to inaccurate readings from the malfunctioning secondary HO2S. Additionally, you might experience various engine performance issues, such as rough idling or hesitation during acceleration, reflecting the inability of the ECM to optimize the air-fuel mixture. Lastly, increased emissions might present themselves as the vehicle may fail to meet regulatory standards, potentially resulting in a failed emissions test. These symptoms underscore the importance of addressing the DTC promptly to maintain both vehicle performance and compliance with emission standards. The first step in troubleshooting DTC P0141 involves problem verification. Begin by turning the vehicle ignition to the on position without starting the engine. This action allows for necessary diagnostics to be performed. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs. Clearing the DTC resets the system and prepares it for a fresh diagnosis. After clearing, start the engine and allow it to idle in a stable condition. While the engine idles, check for any pending or confirmed DTCs again using the HDS. If DTC P0141 is indicated at this stage, It signifies that the failure has been successfully duplicated, warranting further diagnostic actions. In this second troubleshooting step, focus on checking the fuse number D21, which is a 10-amp fuse located in the under-dash fuse/relay box. Begin by turning the vehicle to the off-lock mode prior to any electrical inspections to ensure safety. Inspecting the fuse is crucial, as a blown fuse indicates that the IG1 ACG wire may be shorted somewhere along its path to the secondary HO2S. If the fuse is intact, it suggests that the IG1 ACG wire is not shorted, and you should proceed to the next troubleshooting step. In case the fuse is blown, repair the short circuit in the wire and replace the fuse as part of your corrective actions, ensuring reliable heater circuit functionality. The third troubleshooting step focuses on checking the internal heater resistance of the secondary HO2S. First, ensure that you disconnect the secondary HO2S 4P connector, which allows for safe measurements. With the sensor disconnected, you should measure the resistance between test points 1 and 2. This test should be conducted while the vehicle is in the off-lock mode to avoid erroneous readings. The expected resistance value should fall between 5.4 to 7.3 ohms at room temperature. If the resistance is within this range, it indicates that the heater is functioning correctly, allowing you to move on to the next troubleshooting step. Conversely, if the resistance falls outside this specified range, it may point to a defective secondary HO2S, necessitating its replacement. In this step, the focus shifts to verifying the internal circuit of the secondary HO2S for continuity. After ensuring the vehicle remains in the off-lock mode, check for continuity between test points 1 and 2. It's necessary that the secondary HO2S 4P connector remains disconnected during this test to prevent any interference. A successful continuity test confirms that the internal connections within the sensor are intact. If continuity is detected, it often indicates that the secondary HO2S is functioning properly, requiring its replacement if continuity is not present. In essence, this step is critical in determining whether the internal circuitry of the secondary HO2S is intact or broken. The fifth step involves checking for any potential shorts within the SO2 HT line. To begin, jump the SCS line using the HDS, ensuring this is performed with caution and after waiting for more than 1 minute. This action prepares the system for the next test. Next, disconnect the PCM connector C, which houses multiple circuits essential to the operation of the HO2S. With both the secondary HO2S 4P connector and the PCM connector disconnected, measure for continuity between test points 1 and 2. If continuity exists, it indicates that the SO2 HT wire is shorted, necessitating repairs to this wire between the PCM and secondary HO2S. If not, proceed to the next step for further diagnostics. Step 6 emphasizes checking for any potential openings within the SO2 HT line, an important step in isolating the root cause of the DTC. With the vehicle still in the off-lock mode, and both the secondary HO2 S4P and PCM connectors disconnected, continuity needs to be checked between test points 1 and 2. The primary goal is to confirm whether the circuit is complete or if there's a break preventing the flow of electrical current. Should continuity be confirmed, it suggests that the SO2 HT wire is functioning correctly. In cases where continuity is not present, necessary repairs should be conducted on the open wire between the PCM and secondary HO2S, which is critical for proper sensor operation. In the final troubleshooting step, we measure the voltage between specified test points of the IG1 ACG wire to verify its integrity. Begin by ensuring the vehicle is turned to the on mode which is vital for allowing power to the circuit. With the secondary HO2S 4P connector and the PCM connector disconnected, measure the voltage between test points 1 and 2. Battery voltage is expected at this stage if the IG1 ACG wire is intact. If the voltage is present, it suggests that the IG1 ACG wire is functioning correctly, allowing you to check for any authorized service information related to the DTC. Conversely, if battery voltage is absent, this could indicate an open wire needing repairs between the secondary HO2S and the designated fuse in the under-fuse relay box. After completing all necessary repairs related to the DTC P0141, it is crucial to verify that the issues have been resolved effectively. Start by clearing the diagnostic trouble codes using the Honda Diagnostic System HDS, which resets the system and ensures any previously stored faults are removed. Following this, monitor the vehicle's performance during a test drive to observe if the symptoms have been rectified. Pay close attention to the engine's response, fuel efficiency, and emissions levels, as these are indicators of successful repair. Finally, check for any reoccurrence of DTC P0141 by performing another diagnostic scan. If the code resurfaces, it may indicate further underlying issues needing attention. To prevent the reoccurrence of problems related to DTC P0141, it's essential to engage in regular preventive maintenance. Begin by routinely inspecting the wiring associated with the secondary HO2S and the PCM connectors for any signs of wear, fraying, or corrosion, which may lead to electrical malfunctions. Additionally, ensure that all connectors are secure and free from moisture or contaminants that could impede electrical connection. Regular maintenance of the exhaust system is also advisable, as foreign materials can affect sensor performance and lead to damage over time. By adhering to these preventive practices, you can extend the lifespan of both the HO2S and related components, thereby protecting against unnecessary repairs. In conclusion, addressing DTC P0141 requires a systematic and thorough approach to diagnostics and repair. Each troubleshooting step is designed to isolate potential faults, from verifying the vehicle's electrical circuits to checking the functionality of the secondary HO2S heater. Proper identification and repair of these components is essential to ensuring optimal engine performance and emissions compliance. Furthermore, engaging in regular preventive maintenance can significantly enhance the longevity and reliability of the vehicle's exhaust system and its components. By following the outlined troubleshooting steps meticulously, technicians can confidently resolve this issue and help maintain the Honda CR-V's overall performance integrity. Please like and subscribe to the channel. See you next time!